Hello out there, welcome to this tutorial on binary numbers. In this video, we'll be looking at conversion, where we'll be converting from binary number to decimal number, as well as decimal number to binary numbers. So we start with the first problem. Problem 1, convert the following decimal numbers to binary numbers. We have a 74, 97, and 118. So all these numbers are decimal numbers. If you are writing numbers in decimal numbers, that is base 10, you don't need to indicate the base. Otherwise, you have to indicate the base. So we start the solution from A. To convert this 74 to binary number, we are going to use a tabular form. Here we write the number, which is 74. We divide by 2 and then keep the remainder. So 74 divided by 2 gives 37, remainder 0. Again, we go ahead to divide 37 by 2 and keep the remainder also. 37 divided by 2 gives 18, remainder 1. Then 18 will be divided by 2 to keep the remainder. 18 divided by 2 gives 9, remainder 0. Now 9 divided by 2 gives 4, remainder 1. 4 divided by 2 gives 2, remainder 0. 2 divided by 2 gives 1, remainder 0. Then finally, 1 divided by 2 gives 0, remainder 1. We then read the remainder from the bottom to the top to give us the equivalent of the number in binary numbers. So we have it as 1, 0, 0, 1, 0, 1, 0, then base 2. Therefore, 74 in base 10 is equal to 1001, 010 base 2. So we then go to B. The same way, we have our 97 continuously dividing by 2 and keep the remainder. 97 divided by 2 gives 48, remainder 1. 48 divided by 2 gives 24, remainder 0. 24 divided by 2 gives 12, remainder 0. 12 divided by 2 gives 6, remainder 0. 6 divided by 2 gives 3, remainder 0. 3 divided by 2 gives 1, remainder 1. And finally, 1 divided by 2 gives 0, remainder 1. In the same way, we read the remainders upward. That's giving us 1, 1, 0, 0, 0, 0, 1 base 2. And that's it for B. We then go to C. In the same way, we have 118 to be continuously divided by 2, and the remainder will be kept. So 118 divided by 2 gives 59, remainder 0. 59 divided by 2 gives 29, remainder 1. 29 divided by 2 gives 14, remainder 1. 14 divided by 2 gives 7, remainder 0. 7 divided by 2 gives 3, remainder 1. 3 divided by 2 gives 1, remainder 1. And finally, 1 divided by 2 gives 0, remainder 1. We read upward as usual. That's giving us 1, 1, 1, 0, 1, 1, 0, base 2. And that's all for problem 1C. And then we go to problem 2. For problem 2, convert the following binary numbers to decimal numbers. So we start with A. So to do that, we are going to number the digits of these numbers, starting from the last digit, and we start the numbering from 0, 1, 2, 3, 4. So we now pick the first digit, which is 1, times 2, which is the base, raised to the number given to the digit 1, that is raised to the power 4, then plus 0 times 2, that is the base, raised to the number given to the digit 0, which is 3, then plus 1, which is the next digit, times 2, the base to the power of 2 again, then plus 0 times 2 to the power of this 1, then finally plus 1 times 2 to the power 0. So you see, these ones that are 0 will always return 0. We can cancel them out because 0 times any number gives 0. 2 raised to the power 4 is 16. Multiplied by 1 gives 16. Then 2 raised to the power 2 gives 4. 4 times 1 gives 4. Then finally 2 raised to the power 0 gives 1. 1 times 1 gives 1. So we have 16 plus 4 plus 1 giving us 21. And this 21 is a decimal number. So that's all for A. We then go to B. We have 110110. Again, we are going to number the digits starting from the last digit. This is 0, 1, 2, 3, 4, 5. So in the same way, we pick the first digit, which is 1 times the base 2 raised to the power 5. Okay, then plus 1 times 2 raised to the power 4. Then plus 0 times 2 raised to the power 3, plus 1 times 2 raised to the power 2, then plus 1 times 2 raised to the power 1, then plus 0 times 2 raised to the power 0. So those with 0 again will always give back 0, so we cancel them out. Then we go ahead to simplify what is remaining. 2 raised to the power 5 is 32 times 1 gives 32. 2 raised to the power 4 gives 16. 16 times 1 gives 16. Then 2 raised to the power 2 gives 4. 4 times 1 gives 4. 2 raised to the power 1 gives 2. 2 times 1 gives 2. And that's all we simplified. Adding this, we are going to have 54 as decimal numbers. So we then go to C part of the problem. 1010101 in base 2 to be converted to decimal numbers. We again number the digit from the last digit starting from 0, 1, 2, 3, 4, 5, 6. So we pick the first digit, 1 times 2 raised to the power 6. Then plus 0 times 2 raised to the power 5, plus 1 times 2 raised to the power 4, then plus 0 times 2 raised to the power 3, then plus 1 times 2 raised to the power 2, plus 0 times 2 raised to the power of 1, then finally plus 1 times 2 raised to the power 0. We said the ones with zeros are going this, and this. Then 2 raised to the power 6 is 64. Multiplied by 1 gives 64. Plus 2 raised to the power 4 is 16 times 1 gives 16. Plus 2 raised to the power 2 gives 4. 4 times 1 gives 4. And finally, 2 raised to the power 0 gives 1. 1 times 1 gives 1. So summing this up, we have our final answer as 85 in decimal. So we are done with problem 2, and this is the highest we can take in this tutorial. Thank you for watching. I hope you enjoyed it. Until we come your way again, goodbye.